So, looking at few algorithms on the internet and solving a Rubik's cube is not what is meant by solving a Rubik's cube. It is just what it means is like you can memorize few things and you can recall them and you can replicate them. That's all, right? What solving means is you get the puzzle, you don't know how to do what, which movement makes what piece go where, and you try to figure it out. And there are basically two ways in which you can do this. One of them is like you try to analyze, try to visualize uh, how a particular uh, subcube moves when you do a particular movement, and this is a tougher way of solving the Rubik's cube. There is the second way, which is analysis. Not analysis, like you do a particular movement and then you check which piece moved where, not visually, but by writing it on a piece of paper, and then you try to synthesize a method through which you can actually direct a particular piece to move to a particular place. And doing this for various kinds of movement, you can actually get 4 5 specific moves which does not affect other pieces than the one that you are targeting. This is actually a significantly superior method for this cube case than the first method, which is visualization. Here also you need visualization, some kind of visualization, but your visualization lies on a piece of paper. Here I change something and I expect a change, and I reassign how that change occurred. I mean, what that change is to a particular movement that I did. So the thing that I said is actually the way to solve the particular Rubik's cube, that 3x3 Rubik's cube that this video is about. So now if you want to try this method, which is not actually cheating, I will say it's a different way of thinking, then feel free to pause and try. And after 2 seconds, I will be discussing my way of solving that. So the way that I solved this Rubik's cube is by dividing the solving procedure into 4 different phases, and the first one being the simplest. In the first phase, I just solved the first layer, full first layer, I mean. So the this side also coincides with the middle pieces in terms of color, and the upper face is actually fully of the same color. Talking of the second phase, we will be solving the corner pieces of the last layer. And why is that, and why is not solving the second layer in the second phase? This is because I did that, like I did solve the second layer in the second phase, then I tried to solve the third layer in the third phase, and I reached only to the point that I was able to solve first layer, second layer, and the and like a plus structure on the last layer, and I was not able to move those corner pieces. So I realized that since I'm not able to move those corner pieces, means that I can move them and place them at their required positions before solving the third layer, and have them in their required positions, and then solve the second layer and try to solve the third layer so that the corner pieces won't be affected. This is because I realized that the corner pieces don't move when I try to solve the last layer. So if I fix those corner pieces perfectly and then try to solve the third layer, the corner pieces won't be affected either, which is a good thing, right? Because the corner pieces are in their perfect positions, and I don't really want to mess with that. So let us now try to reorient those last layer corner pieces. So you see I have 1, 2, 3, 4 in this fashion, and I will be trying to move them with respect to themselves. So I bring this down. Suppose this piece that is moved is A. I move this, and in this step you move another black piece which is on the farther side, and now you try to bring that back to its place by moving like this and not trying to retrace what you did earlier. And now you finally try to bring that A piece back to its place by performing this sets of motion. Um, now if you see the last layer, it is now 1, 2, 3, 4 in this fashion, which means it has rotated, that too anti-clockwise. So right now, if you see, the sequence is like 1, 3, 2, and 4. But for correct matching of the corners with the middle pieces, I need to have like, if I change it, I need to have 1 here because orange, orange, and okay, no, so here, yep, orange, orange, green, green, and I need to have 2 here because 2 has red and green, which is red and green, and so on for all the pieces. But right now I have like 1, 3, and 2, 4. So keeping 1 as fixed, I can move the other uh, 3 corners, right? So how can we do this? Like I have assigned this as this, and this as this, and this as this, and I will be moving the papers to show how you can go about doing this. So you can fix this, and you can rotate this like anti-clockwise. So this goes here, it goes here, and it goes here. So now you have a perfect sequence like 1, 2, 3, 4, just the way that we need it to be. So let's do that. So here I go. I will find the second corner, which is this one, and I will keep this as fixed and move the other 3 in anti-clockwise direction. For that, I need to have the second corner at my right hand side, and I should go like yep, it goes here. I will bring that up like this, and finally it is solved, and I have successfully moved all of this anti-clockwise, and I've got 1, 2, 3, 4. So here is the second transformation in the second phase itself. I won't be doing it as a trial run because I don't want to mess up the initial configuration, which I can mess up and re-mess up, but I don't really want to. I will show this on a piece of paper like right here. So the transformation that we are going to do right now uh, will change. We'll swap the corners diagonally. So this part will go here, and this part will go here. This corner will go here, and this corner will go here. And specialty of this transformation is this corner will only sweep across all the corners and reach here, which means that if it is in this configuration, it will come like here with this the same configuration, which means that green will be here, and yellow will be here, and orange will be here. And for all the other pieces, what will happen is when they move diagonally, they will actually change their orientation from being like this to being like this. So here if you see, it goes from here from this orientation to this orientation, and same happens with this corner also. It goes from this orientation to this orientation. That is what I have shown with this color coding thing. So this piece has actually shifted to here, and this is its initial state, and this will be its final state, and this will remain the same, and this will transform similar to this case. So let us do that. Let us show what the transformation is. Nice kind of background, right? So let us start with the transformation. So I will keep the corner one fixed. So this one is like this one is that. So I expect that this will not change, and this will swap, and this will swap, and this will swap its orientation, and obviously the positions will change for all of them. But that doesn't matter for now, because the relative sequence will remain the same, because when this changes, it only means that now the sequence is clockwise, and again when this changes, it means that from clockwise it again changed to anti-clockwise. So in total it just remains the same. Let us start with the transformation. I will keep one as fixed in its orientation terms, and let's start. So one is here, so one goes like again to the right hand and back, and the transformation is bring this up, bring this 2 times, rotate that 2 times, bring that up, up I mean, and then again bring this, and finally, oh my god, yep, I hope that it is done. Finally, this is the state of the cube after that transformation, and now let me explain like what is the need of this transformation. The need basically is that when you did that previous transformation where you arrange them in the perfect order, we did not have like all the yellows on this side, which is what we will be trying to achieve from this transformation. So you see that this changes the orientation a bit biased way. So the corners that are facing away and left and away from you are like not changed. So we can take that into our benefit and do some calculations in order to predict how things will change, and like how can we achieve our required change of having all the yellows on this side by performing few of this transformation repeatedly with. So basically before doing that, I will be showing a few conventions that I'm going to follow just in order to have it written on a piece of paper more conveniently. So if you see, the yellow is on this side, is on its desired position, which is facing the yellow center, and I will be assigning the sub cubes that are like this as 0, or in general 3n, so my multiple of 3 basically, and 0 is also multiple of 3. I'm assuming. So I will be saying this as 0, and if you see this one, it only needs like one transformation in order to go to its desired orientation. So I will be saying that this is currently at 2, because if you do the transformation once, which is like adding 1 to this, you will get 3, which is again a multiple of 3n, and so it's in the required orientation. And suppose that the yellow was not here, but it was like right here, which would mean like you have to do the same transformation twice, which means adding 1 to that cube's orientation, that convention, twice, which means you would have to write that as 1 and not 2. uh, but fortunately for our case, we have this as in 2 orientation, this as 2, and this as 2 orientation. So we are fortunate enough, and I will show you that it does not matter which kind of combination you have right here. You can always bring all of them to 0 or 3 and multiple of 3 and I mean. So right now we have a simple like orientation of all the 3 except this one. Like they are like one step away from their required orientation, all 4 of them I mean. So I will be fixing this as the constant. So this subcube will represent this part, and the other 3 will increase their conventional number by 1 and will go to their required positions. So that is what I will do right now, and as predicted, all of them landed in their perfect orientation.